right. All right, now the first thing we have to do, we have to learn off some formulas. So this will take me a few minutes to explain. First of all, not all of these formulas are shown on the formula sheet. Let's start off with the yellow box, this formula over here, all right? Now let me explain why I have three formulas over here. First of all, right, whenever you see sine squared x, or you see something like tan squared x, this is the same exact thing as sine x, and you put the whole thing in brackets squared. Or tan squared x is really tan x in brackets squared. They just choose to write it like this because it looks a little bit cooler, I guess. There's no really good reason for it, right? It just looks cooler, that's all. Now, with that being said, right, I want you all to get your calculators out. And what I want to prove that this first formula is actually true. I'm not going to prove all of them. I just want to prove one of them is true. And then I want you to take my word afterwards that the rest of them are true also. So let's put down the first formula. Sine squared x plus cos squared x. I want you all to choose let's choose a random angle. Remember, x is going to represent the angle. We could choose any angle in the world. Let me choose a really crazy angle, 49 degrees. That's not even a nice angle, like what, 30 degrees or 60. Then it will work for any other angle. So here's what I want you to do on your calculator, but you have to type it in straight on your calculator. Type in sine 49, well, open brackets, close brackets, and put the square. Do not press equal yet. Then press open brackets, cos 49, because we're pretending the angle x is 49. Close the brackets and square it. Type that in on your calculator and tell me if you get exactly 1. You're always supposed to get 1, no matter what angle you choose. But type it in and prove it to yourself. It's important that you build confidence in yourself that the formula is true. Right, so I'll wait on everyone to reply. Right, so now that you have shown yourself that this is actually true, right? Sine squared plus cos squared is always equal to 1. This means in the exam, anytime you see sine squared plus cos squared x, it's perfectly okay to throw it away and replace it with the number 1, right? And that's going to be important in the exam sometimes. Also, you could do the reverse. If you see the number 1, and for some strange reason that is bugging you and it's getting on your nerves, you could throw away Mr. 1 and replace him with what? Sine squared x plus cos squared x. It's also very, very important to note that this formula only works when you have a square. It doesn't work for cube. It doesn't work for any other power. One of the most common mistakes that I've seen is that sometimes in the exam, you'll see sine x plus cos x. And students think it's okay to replace this with 1. Do you all think that's okay? If you saw sine x plus cos x, and is it okay to throw that expression away and replace it with 1? Right, the answer is no. I know it resembles the squared, but it only works when it has a squared. All right, so that's this formula over here. What I want you to note, right? Only the top formula is given in the exam. Only this one over here. But you all know that you could transpose a formula. Now, I made a slight mistake over here, and I made the same mistake on all the slides, right? You all realize you could throw across sine squared x on the other side. And if you throw across positive sine squared x, you will actually get what? Minus sine squared x. So that's a small mistake I made on all the sides. It wasn't intentional. So in other words, if you transpose this formula, you will get the second expression, which means in the exam, if you see cos squared x anywhere, you can throw it away and feel free to replace it with 1 minus sine squared x if you choose. And of course, you can do vice versa. And the third one here is this. If you decide to make sine squared the subject, like you throw across the cos squared, you will get 1 minus cos squared. And of course, you can replace either one with the other one. So I want everyone to take down everything in yellow. Okay? Right. And the yellow one is just the same formula transposed 2 times, 2 additional times. But I don't want you wasting time in the exam transposing. I want you to know it by heart. It will save you so much time in the exam. The pink formula is just a formula you need to learn off. Anytime you see the pattern 1 plus tan squared x, if you want, you can replace it with 1 divided by cos squared x. That's if you choose to do that, right? Sometimes making the change helps you in the question. And of course, some of you are asking, well, how will I know when it's the correct time to change it? Like, does it make sense keeping the 1 plus tan squared x? Or does changing it to 1 and cos squared x have an advantage? The truth is, only experience from doing a lot of questions will allow you to make that decision, right? There's no clear-cut rule to indicate when it should be replaced, right? So take down the pink rule. Ruler. The green rule says that anytime you have tan x, it's perfectly okay to replace it with sine divided by cos. Now check this out. If you cross multiply and make cosine the subject, you will get the kind of dark, but that's orange, right? So anytime you see cos x, it's okay to throw it away and replace it with sine divided by tan if you choose to do so. And if you cross multiply again to make sine the subject, sine x is the same thing as tan x multiplied by cos x. So these 3 formulas with the dots are just different versions of each other. They're just transposed versions of each other. Now I want to explain the blue one, a real time saver in the exam. If, I don't know if you all ever bounce this up in normal maths. If I have y is equal to 2/3, I just say if. We all know y is the same thing as y on 1. If I decide to put 1 on y, like I decide to flip this side, did you all know it's perfectly okay to flip the other side as well? That this is mathematically correct? I'm not too sure if you're supposed to bounce up that at some point in normal maths class. So what I'm trying to say is this green formula, remember, here's tan x is equal to sine x on cos x. So if one day you see 1 on tan x and you're struggling what to replace it with to save time in the exam, 1 on tan x, if you flip this side, then it's mathematically okay to flip the other side. It's a real time saver in the exam, okay? Right? So take down the blue one, so you're taking down all the colorful ones. And when you all are finished, I want you all to tell me if you all recognize this formula from regular boring maths class. It was one of the 21 videos you had to do in normal maths class. It falls under factorization. What's the name of this formula? Everyone should be able to recognize that by now. Right, so the name of this formula is just called the difference between two squares. All right. And I'm going to trust that everyone remembers how to use this formula, right? So, all right. Now, the good news is you see these formulas on your right-hand side. For each question that I have today, I put the chart to the right, just until everybody gets what really accustomed with it. So let's move on to our first trigonometry identities question, right? I want to show you how it comes in the exam. So let's move on. Right. So I want everyone to take down this formula, not the formula, this question here. Take down the word in here, and this is your first question here. And remember, in all the slides, I made a slight mistake. This is supposed to be what? Minus signs. I forgot to change the positive to a negative when I was throwing it across. I think that's the only mistake I made. So take a few seconds and I will show you how to do the first question. Right, so here's what you have to do. In these types of questions, you must have an equal sign, right? Sometimes they put 3 equals here, right? Don't let it bug you today. Your job is to take one side of the equal sign and use the formulas to manipulate it until it looks like the left hand on the other side. Now, at no point in this question, you're supposed to transpose. You're never supposed to take like the minus cos squared theta and throw it across to get a positive at no point in time. So at the beginning of the question, here's what I want you to do. You call this side the left-hand side because it's on the left-hand side of the equation. And this side is called the right-hand side. Everyone write it on top. The examiner will want to see that. Okay? Left-hand side and right-hand side. What you need to do is make a firm decision which side you are choosing first. Now, normally in CSEC, you will always choose the, well, 99% of the times, you will choose the left-hand side. But the rule of thumb is that you have to choose the more complicated looking side. So it just so happens that the left-hand side looks a little bit more complicated because it has more squares. But anyway, make a note over here to tell the examiner that you are choosing the left-hand side. So physically write it in. Choose left-hand side. So the examiner will know, hey, you are focusing on the left-hand side and you are leaving out the right-hand side for the time being. So all you have to do is write back the left-hand side. So you have plenty of space here now. When we are finished with the left-hand side, it's supposed to look like the right-hand side. You will notice that the right-hand side only has cos squared. It has no sine squared. So it comes like the right-hand side seems to get rid of all the sine squareds or all the sines. If you go to our formulas, is it okay to replace this with 1? Is sine squared minus cos squared equal to 1? Can I use the first formula directly? Is it okay to replace it with the number 1? Right, I thought you all would have fallen for the trick there. The answer is no, right? Because sine squared x plus cos squared x is 1. This is sine squared, but what we have in the middle, a minus. The formula cannot work, okay? And some of you all are making good suggestions. A lot of you all are telling me to look over here. This formula tells me anywhere I see a sine squared x, if I wish, I can throw away a sine squared x and replace it with what? 1 minus cos squared x. So let's try that. I mean, let's see if it actually helps us. So I'm going to take Mr. Sine squared x, but it's theta here, right? But the x is represented by theta. I'm allowed to throw away sine squared theta and replace it with 1 minus cos squared theta. And what do I have waiting here? A minus cos squared theta. One, if I have minus cos squared theta and I minus another cos squared theta, won't I get minus 2 cos squared theta? We finished. We made it look exactly like the right-hand side. So then you can just write a sentence. Hence, it's proven. Okay, let's write a simple sentence. Okay. But this one real easier. You're never going to get one easy like this in the exam. But this one here is just to show you the concept of how you take the left-hand side. You use one of the formulas, right? And or a combination of formulas to make it look like the right-hand side. I know some teachers will say put a box, right? Y'all want to help me? For those who teachers say put the box, do we have to put the box on top or the underneath? I never use the box, but I've heard that some people just use the box. Well, where exactly do I put the box instead of writing the sentence? Okay, so, right. So some teachers, they just draw a box here. The box represents the words, hence it's proven, right? But when I went to school, I just used to write the sentence, okay? I guess the boxing is a fancy thing. All right, let me know when you're finished with everything on the screen. All right, so next question now. Question 2. All right, so write down this question, okay? Now, this is an intentional question, right? Before you jump the gun, right? Some of you are going to say that tan squared plus 1 is the same thing as 1 plus tan squared. And that is true. And you can just what? Use the pink formula. But I want to do this question the hard way. I wanted to show you all that how people know that tan squared theta plus 1 is actually 1 on cos squared theta, right? It's really, really important that you know this one. Right? So I think you all know what to do in the first place. We have to call one side the left-hand side, right? And one side the right-hand side. We're going to pretend that this pink formula doesn't exist. And we're going to do this question the hard way. Right. So let's choose the left-hand side. So we're going to let the examiner know. Choose left-hand side. So I'm going to only write the left-hand side here. Tan squared theta plus 1. And when we're finished, it's supposed to look like the right-hand side. No problem, shifter. I want you all to focus on the green formula. Remember, tan x is the same exact thing as sine divided by cos. Remember, tan squared theta, this is the fancy way of writing it. Couldn't we write it like this? Tan theta and put brackets here and put the square? Right, now I showed you that at the beginning of class. So everyone take down that step. Let's write it the less cool way. With that in mind now, wherever I see tan, I can replace them with what? Sine on cosine. So inside here, remember, that's a brackets and you have a squared here. I could put what? Sine theta divided by cosine theta. And then we have the annoying 1, positive 1, waiting on the outside. Take down up to there. Once we reach there, you notice how you have the brackets and a squared lurking on the outside? Doesn't brackets mean that this squared belongs to both of them at the same time? So this squared belongs to the sine, and it also belongs to the cosine. So I guess you could get rid of the brackets now and write it like this. sine squared theta divided by cos squared theta plus 1, right? Take down up to there. No problem, Emily. Now, a lot of people might be tempted, right? I mean, it's a little bit a trial and error, right? Some people will see the number 1 here. So you know what they will do? They will take the number 1, throw it away, and replace it with sine squared plus cos squared. Now, there's no mathematical law that says we can't do that. But I guarantee you, if we do that, even though it's mathematically correct, like I throw away this one and replace it with this expression, it will not help things. It will just make the question more complicated, and we will move further and further away from arriving at the right-hand side. And how do I know that? I only have one answer for you there. Experience, that I did enough questions to know that that is not the correct way to go about the question. So what do we do? Well, when we reach here, I know 1 is the same thing as 1 divided by 1. We have a fraction here, and we have a fraction here. Couldn't we add the 2 fractions using LCM? So let me write it back here. I have sine squared theta on cos squared theta plus 1 on 1. The LCM would be cos squared theta. Cos squared theta into cos squared theta is 1. 1 by sine squared is what? Sine squared theta. Plus 1 into cos squared theta is cos squared theta. Cos squared theta by 1 is another cos squared theta. So this cos squared theta is the LCM. So I use the LCM to merge the fractions, to combine the fractions. Do you all see the answer now? Look at this. Once I reach here, isn't sine squared theta plus cos squared theta? Now I could use it by using it in this direction. Couldn't I throw away this and replace it with 1? And look at it. I arrive at the right-hand side. I get the right-hand side. Hence, it's proven. Okay? You can put your box, you can put QED, whatever your teacher wants you to put. But those who now came into class, right, on all the slides, I made a small mistake. This is supposed to be what again? A minus sign, right? A minus here and a minus here. Let's see what the third question is. I think now the questions will start to get a little bit harder. Oof. All right. Well, take down this question, right? And we have to make a decision. Well, I guess we could choose. We're gonna choose the left-hand side again, right? So you have a left-hand side or a right-hand side. Choose. You all want to take a shot at it? See if we can get it out, no? Question. When you all see the answer, you're gonna like slap yourself on the forehead, right? So, all right. So here's what I did. We choose the left-hand side. 1 minus cos squared theta. All right. So I'm going to look at the first formula. I know some of you all went to this formula by mistake. Not by mistake. It's a good guess. Because you thought that if you throw away cos squared theta, you could replace it with 1 minus sine squared. And you are allowed to do that. But I'm guessing that when you did that, it didn't help the case. The question did not end up looking like the right-hand side. So wherever you see the number 1, like this guy here, You can throw that away and replace it with what? Sine squared theta plus cos squared theta. And then you have the what? The minus cos squared theta over here. But you all notice something? You end up with positive cos squared minus cos squared. Won't these two cancel out? And you'll be left alone with what? Sine squared. All right, it still doesn't look like this here. But isn't sine squared theta the same thing as sine theta in brackets squared, which is the same thing as what? Sine theta multiplied by our next sine theta. Isn't that what squared means? To multiply by itself? And if you do that, if you look down here in the, I'm not sure what color this is, we'll just call it red, right? Couldn't we take one of the signs and replace it with tan multiplied by cosine? Just one of them, not both of them. And there's no law saying we have to replace both of them. It's up to us if we want to replace both or one or none, right? And if we do that, I'm going to replace this one. Sine is the same thing as tan multiplied by cos is the same thing as cos multiplied by tan, right? You all see it now? We got the right-hand side. Hence, it is proven. Put a little exclamation mark and a happy face. How much of you all were overthinking this question? Like you end up with a whole set of squares, like you replace it with the second one here, and it just got worse and worse and worse after that point. Right? All right. All right, have fun with this one. Now, this one, you definitely cannot choose the right-hand side, right? I'm 100% sure you have to choose the left-hand side here, right? So get started, right? The only way to really learn this is you have to attempt it yourself. You have to make the mistakes. You have to build experience. Yeah. Now, the easy way to do this question, right? We're choosing the left-hand side, right? So we let the examiner know that, hey, which side we choosing. So we have cos squared theta, open brackets, 1 plus tan squared theta. Now we see from this pink rule here that 1 plus tan squared is the same thing as 1 divided by cos squared, right? So immediately we could throw this away in the brackets, right? And of course, you can replace it with 1 on cos squared theta. So we have a squared here. Won't this and this cancel out to give you what? 1. But that's the easy way of doing it, right? Well, what I want to do, I want to work out this question without using this formula. Because I have a good feeling that the teacher will want you to do it the long way. So let's cater for that way. I'm going to do it on this side here since we have some space. What we could do instead is multiply out the brackets, right? So we're still choosing the left-hand side. So what I'm going to do, I'm going to multiply everyone inside here by cos squared theta. Cos squared theta by 1 is cos squared theta plus cos squared theta multiplied by tan squared theta is cos squared theta multiplied by tan squared theta. There's nothing much we can do there. Now, once we reach here, keep your eyes on the green formula. Remember, tan x is sine divided by cosine. And let me write this back properly so we have all the steps for the examiner. Tan squared, the uncool way of writing this, remember, is like this. You could probably put the tan x in brackets, and then you put what lurking on the outside, a squared. So this really means what? Tan is the same thing as sine divided by cosine. So he could throw away that tan and replace it with sine divided by what? Cosine. Once we reach there, we know everybody inside the brackets gets what? Squared. So we have cos squared theta plus cos squared theta. The sine gets squared, so you get sine squared theta, and this cosine also gets squared. You all realize something is going to cancel out on top and underneath. Underneath you have a cos squared, on top you have a cosine squared. What are you going to be left with? You're just going to be left with cosine squared plus sine squared. Cosine squared plus sine squared, if we use this formula, is equal to what? 1. Hence, it's proven. Your teacher will want to see this way, right? And I believe CXC will want to see this way, because this question too easy if it just runs straight to this formula. Okay? Right? Oh, and for those who now came to class that have a few errors, if over here it's supposed to be a minus sign for these two formulas, right? Made a small mistake when I was making the slides. Let me know, please, when you are finished. All right, so what we want to do, right? We're not using this formula here. I want you all to try to work this out the reverse way. I want you all to choose the left-hand side, choose this side, and see if you can arrive at the right-hand side. Just see if it's possible to work it the reverse way. Right. All right. So the hint was to use the first formula, right? So if I have 1, we choose the left-hand side, divided by cos squared theta. Well, 1 can be replaced with what? This 1 here can be replaced with sine squared plus cosine squared. So I'm going to do that. Sine squared theta plus cosine squared. Now, how do we interpret this? For those who were in Tuesday class, I think I had mentioned this. Like if you have x plus y divided by 2, and you have one big divide sign here, doesn't this mean both of them at the same point in time get divided by 2? So you can write it like this: x divided by 2 plus y divided by 2. It's the same concept here. Instead, you have x, you can think of this as x, this as y, and this as what? 2. So this means both items at the same point in time get divided by cosine squared. So you're going to end up with sine squared divided by cosine squared plus cosine squared divided by another cosine squared. We know cosine squared divided by cosine squared is going to give us the 1. And over here, sine divided by cosine will give us tan. So if we have sine squared divided by cosine squared, guess what we will get? We will get tan squared plus, and when you divide this, you get 1. Hence, it is proven. Right, so take down the work in there. All right, so I have to put some hard ones here just in case, right? This here is a multiply. This dot here is a multiply. Try this question, right? And let's see what you come up with. Right? I'll give you some advice with how to, LCMs still give a lot of people problems. So like, for example, right? If you have 2/3 plus 4/5, we know the LCM is what? 15, right? And then they say 3 into 15 is what? 5, 5 by 2. You all know the general procedure. But let's just pretend that you have no idea of how to find LCM. What else could you do? If you cannot find LCM, the question doesn't shut down, right? Here's a real common way to get by addition or subtraction of fractions. All you have to do is take the two denominators and multiply them, but you leave it as that. You don't say 15, you just leave it as what? 3 multiplied by 5. Whenever you leave it like this, all you have to do is say 3 into this always leaves you with the other expression. So you see how the 3 and the 3 match up? It will leave you with the 5. And then whatever you're left with, so you say 5 by 2 is what? 10 plus. And then you say 5 into this. But you notice the 5 and the 5 match up. It is always leave you with the other item. So 3 by 4 is 12. Let me use a more complex example. Let's say you have m divided by xy plus, I don't know, k divided by 1 minus x. Imagine in primary school, somebody asks you to add that, but you'll freak out, right? Because you only know how to find the LCM of numbers. Nobody has ever shown you how to find the LCM of a complex scenario like that. But don't make it a problem. The two denominators are what? xy, and you put multiply by what? 1 minus x. You just have to put this in brackets so you know they're separated from this, right? xy into this. Notice the xy and the xy match up. It will leave you with the other item. So whatever you're left with, you multiply it by the top. So it will be m multiplied by 1 minus x plus 1 minus x into this. The 1 minus x and the 1 minus x match up. So you'll be left with the xy. xy by k is xyk, or xy multiplied by k. So that's a real useful tip there, no? Like on how to find the LCM or something to substitute the LCM so the question can still work out. Right? It's a real saver. It's a real, what's it called that? Saver. I don't have a better word. Right, so I hope that helps you with this particular question. All right, so let's see if I can help you out here a little bit, give you a little jump start. Well, we're choosing the left-hand side for sure, right? So we let the examiner know, hey, we are choosing the left-hand side. So we have sine theta by 1 plus cos theta, right? Oh, this is a multiply. And oh Lord, guys, I gave you all some bad advice here. What I showed you was for addition and subtraction of fractions. This here is a multiply. Actually, the question is easier now. Right? All right. Since we're multiplying fractions, if we are multiplying fractions, right? Let me say we have this. Let me just put a 5 here, right? Multiplying fractions is pretty simple. The ones nothing could cancel out, you just multiply the top by the top and the underneath by the underneath. 2 by 7 is 14, 3 by 5 is what? 15. But that's how you multiply fractions, right? It should not be any more, sorry, the procedure should not be any different for this particular scenario. I don't think anything can cancel out here because you have 1 plus cos theta here and you have 1 minus cos theta here. Those are two different things, so you can't cancel out anything. So it seems, unfortunately, we have to multiply the top by the top and the underneath by the underneath, right? So When you multiply the top, I guess we can simplify it after. We'll get sine theta multiplied by 1 minus cos theta. We'll expand it after. And underneath, we ended up with 1 plus cos theta multiplied by 1 minus cos theta. The top isn't so bad because we can just multiply every one inside here by sine theta. So we can probably take care of that after. But the underneath part, remember how you multiply this? Remember when we were doing quadratics in math class, how you would multiply out a scenario like this? I don't know if you all remember. Let me just refresh your memory. Let me say you have 7 here. Whenever you have a pair of brackets next to each other, what you have to do is take this brackets and multiply it by the first item. Then you take the brackets again and multiply by the second item. So it will look something like this. You take the 2x plus 7 and you multiply it by x plus, and you take back the brackets again and multiply it by the second item. And then you can multiply out this separately and this separately. Right? So with that in mind now, right? Let's just work out the underneath here. Let's just get rid of those brackets. That is the underneath. 1 plus cos theta is the same thing as 1 minus cos theta, and we multiply by the first item, plus we take back the brackets, which is 1 minus cos theta. Oh God, there's a limited space here. And we multiply that by what? Everybody with me so far? I'm trying to expand this brackets here and simplify it. All right, great. So people are saying, yes, they're with me. So do you all want to take your time now and multiply this out? So at least we get it underneath, under control, right? One by one is 1. 1 by cosine is cosine. Cosine by 1 is cosine. And then positive cosine by minus cosine is minus cosine squared, because a positive and a negative is a negative. If you look at the middle here, you have minus cos theta plus cos theta. Won't those two cancel out? Leaving you with what? Only 1 minus cosine squared. So that is what we get for the underneath. Right? I'm not going to even bother to multiply on the top, because I realize if I multiply on the top, I will move further away from the answer. Right? So look at what we have now. On top, I'm going to leave it as sine theta 1 minus cosine theta, and underneath we got 1 minus cosine squared. That's this guy here. Right? And remember, there was an error in the formulas over here. For all the slides, I'm supposed to correct it. Do you all see that we can use this guy here? 1 minus cosine squared is the same thing as sine squared. So, and we could throw this away now. Now I'm running out of space here, right? So I need to erase this. So I'm going to throw this away. So make sure I have everything written down, because I need to erase. I'm going to throw this away. And replace it with sine squared theta. And isn't sine squared theta the same thing as sine theta multiplied by another sine theta? Instead of writing sine squared, you can write it like that. Notice what happens here now. One of the sines will cancel out with one of the sines. leaving you with exactly with what's written on the right-hand side. 1 minus cosine divided by sine. Hence, it is proven. All right. Well, I think we have one more question left. That's question 7. Look at this mess here. All right, scary looking, right? But get started. Obviously, you're choosing the left-hand side, right? It'll be our last question. Oh, so some people say they had, how you say, maths tests, had maths tests already. All right, but this is the last question we're doing, right? So give it all you can. See your exam. You'll remember this topic called quadratics. Well, you'll remember that you all can factorize a quadratics. If I ask you to factorize this, x squared minus 2x plus 1, do you all think you all could factorize that? Forget the question for the time being. Do you all think you all could factorize that? Remember, when you factorize it, you will get what? 2 pairs of brackets. See if you can get what goes inside the brackets, right? This question stems back from regular boring maths, right? So I want you to think quadratics. So when you factorize this, you'll get an x here, a minus 1, and a minus 1. If you multiply on back the brackets, right, you'll get this exact same expression here. You will see a similarity between this question and this question here. This quadratic has x squared, but you realize this is the same format, but instead of x, it has sine theta, right? It says sine theta squared minus sine theta. So that means you could factorize the top. But if you factorize the top, you will get what instead? Sine theta minus 1 and another sine theta minus 1. The letter x is just being replaced with the word sine theta. So that means if you factorize the top, we get that expression. We're dealing with the left-hand side once again. And underneath, we have what? Sine theta minus 1. But you can pretend this in brackets. Do you all notice 2 things will cancel out there? Boom, boom. Leaving you with the right-hand side. Right? It's a popular type of question that is coming in the exam, right? So make so, right? Right. Right. So take it down. And like I said, that's the last question we're doing for today.